The second algebra topic that we wish to look at when we're first starting this course is the topic of solving equations. And in the couple of examples that follow, what we'd like to do is look at solving linear equations. The numbers that we're going to use as coefficients in these equations are larger numbers because ultimately when we do real-world problems, which will happen shortly, the numbers we are going to use are from practical applications, so our numbers won't be small integers. So the directions for these problems say solve the following linear equations. If necessary, round off the final answer to 2 decimal places. So it may be possible that the answers won't come out evenly, so rounding rules do apply. And then once you're finished, you should always make a habit of checking your answers. So the first equation there next to number 1 says 25x minus 60,000 is equal to 75,000. So our goal is to isolate the variable x on one side and decide upon a value that if we substituted it for x in the original equation, the two sides would be equal. To isolate the x on the left-hand side of the equation, the first thing we want to do is we want to add 60,000 to both sides of the equation. As you see, we have 25x minus 60,000 plus 60,000 equals 75,000 plus 60,000. When we have that, the negative 60,000 will cancel off with the positive 60,000, so we'll have 25x equals 135,000 by doing the arithmetic on the right-hand side. Now to just have x on the left, since the 25x actually means 25 times x, what we need to do is divide the left side by 25, and if we do that to the left side, we have to do that to the right side also. And so we have 25x divided by 25 equals 135,000 divided by 25. And when we finish the arithmetic with that, we have just an x on the left-hand side, and 135,000 divided by 25 is 5,400. Now to have the numbers a little more complicated, we have a second example there. Negative 15.5x plus 300 equals 100. In that particular problem, what you want to do is to subtract 300 from both sides. And when you accomplish that arithmetic, you'll have a negative 15.5x equals negative 200. If we divide both sides by a negative 15.5, the left-hand side is x, and then on the right-hand side, the negative 200 divided by the negative 15.5 becomes a positive number. That doesn't come out evenly, so when you have your decimal places, round it off to 2 digits, and our rounded answer is 12.90. So that's a couple of examples of how this particular procedure should be done.